So hello, are we live now? I believe that we're on. Okay, well, fantastic. Welcome everybody. Welcome to Making Space for Innovation. Welcome Tech Talkers. This is a Tech Talks. It's Bean Path's monthly chat where we explore different fields, points of view, and professions across the world of STEAM and tech. I'm Anik Kirkjian, Bean Path's Director for STEAM and the Makerspace. I'm jumping in today to host this tech talk because we're looking at the world of makers and makerspaces, which as the Director of STEAM and the Makerspace, I do a lot of. This year, Bean Path will be opening their home at the first building in the Jackson Tech District in downtown West. Our home, the Makerspace, is a space for you, the community of Jackson. Our Makerspace is a 6,500 square foot community workshop, which will be full of machinery, expertise, materials, and like-minded people who want to make. We have a basic wood shop, we have a textile shop, we have an electronics bench, a computer lab with 3D printers and a laser cutter. You can make furniture, websites, clothes, apps, jewelries, robots, art, games, parts of machinery, fix things, anything you want to, and anything your imagination really can create. At this makerspace, we support people to make, whether it's for fun, to upskill their career, grow their portfolio, develop or expand their company, explore and develop prototypes and new ideas. So this space is for everybody. It's for everybody in Jackson, from the scared beginner to the expert engineer to the curious and avid tinker. We will have classes, we will have groups, we'll have memberships for you to work at your own pace within your comfort zone. The Bean Path is making a space for innovation in Jackson, Mississippi. And we can't wait to welcome you to the Makerspace, in the fall. So before I go on, a little housekeeping. We are going to start talking about Maker and Makerspace and explain further. The housekeeping is we're going to be dropping a couple of questions in the chat just to make it a little bit fun. There will be a Q&A, and at the end of the day, this chat is for you guys. So feel chatty, open up your chats and drop questions in as we go along, and feel free to respond to the questions that we'll be dropping in as we go along. So that is today, and that's why I'm here hosting our tech talk about making space for innovation. But let's get to the most important person here and why we're here. We have someone who has successfully been making space for innovation for over a decade through her company, Continuous Solutions, and her Makerspace. She was a senior R&D engineer at Intel, Abbott, and Purdue University. She is an expert in organizational processes, modeling, simulation, experimentation, and hardware in the areas of control and system-level integration. She is the principal investigator on projects developing electric propulsion designs for UUV and VTOL applications, as well as the commercialization of a high-performance motor controller for electric vehicles. Wow, we're going to be learning a lot here today, guys. With her team of engineers, scientists, and researchers, they combine the inventor's creativity with the engineer's attention to detail to unlock the answers to our industry's thorniest power and energy problems. She says, we're bridging the gap between commercial development and groundbreaking academic research. So, a true maker at the highest level, who is also supporting her community around her with their own makerspace. I'm thrilled to introduce Dr. Nyah Zarate. Hi.
Thank you, Anik. Wow, that was a beautiful introduction. I don't even know who that person is. All right, well, I appreciate you having me here today, and I'm excited to talk about some of the work that we were doing, or that we are still doing in propulsion electrification, as well as how we utilize our makerspace, who it's for, and how we organize ourselves. So without further ado, I can give a brief overview of a project we're working on, in particular with Navy application or naval applications, just to kind of give you an insight of what we're working on and the project setup. So I will share my screen. Let's see. So this is a tech talk that I gave at, it is a, oh, can you see my slides? Excellent. Okay.
Yes, you're good.
All right. So the work that we're doing at Continuous Solutions is at the intersection of government, academia, as well as research and development. This particular project that we're working on is the power dense rotating machine or motor for propulsion and power generation. So about our company, we mainly focus ourselves in power generation, energy distribution components on motors and drives. And we primarily work with an organization that's a federal program called the Small Business Initiative Research and Development Program, in which you can submit project proposals to solicitations and win award money to develop these products into a pipeline. And so we primarily strengthen our technical team with partnering with universities and research organizations. So it's very important to not work in a silo, but to build out your resources with interacting with other people or other organizations if you have an idea that you want to bring to fruition. The FSU laboratory, which is Florida State University laboratory, has one of the highest power facilities in the world. It's called the Center of Advanced Power Systems. And so you can see the advantage of working with these types of organizations. We're just a small company, 8 years old. And so it's really important to work with these larger organizations. We also have many other contracts in the works, but today I'm going to talk about some of the challenges in the Navy. So this particular project was with the Navy, and we were working on a power dense, so meaning very small, compact, but high power application for propulsion. The Navy is looking to increase its power density, meaning more power for the envelope of a particular motor, a 50% increase from the state of the art that's currently being used today. So what we did was we took the state of the art, which is this red box, put it into a structure in which we can just say, all right, here's the volume and here's the power that's being put out by this particular volume. Now, how can we create a design that is more power dense than what is currently state of the art? And so we used an algorithm that was developed between us and Purdue University to utilize, it's called genetic algorithms, and it's partially AI application where we let the computer, the algorithm run and utilize evolutionary computing to come up with the most power dense solution that we can actually build in-house. And so what we came up with was a significant increase in power density. As you can see, we came up with two side-by-side designs next to this already existing technology, and we've more than increased it by 50%. We actually increased the power density by 109%. And so by taking this design, now we have the blueprint for what we are going to build, right? So first we need to figure out, why are we building something? What is it improving? And do we have all of the information that we need in order to build it? So we did get all the information that we needed to build it. However, 20 megawatts is a massive, massive scale of electric motor, specifically for naval ship propulsion. So we said, all right, we're not going to be able to build this massive motor, but what we can do is we can scale it down to a much smaller size to see if the performance and the power density is going to be achieved with this particular design. So we scaled it down, way down actually, and created a bill of material on all of the parts that we needed in order to assemble this motor. As you can see on the right side of the screen, this is the end product of our reduced scale. So instead of 20 megawatts, we actually did 10 kilowatts machine. And this was completely bespoke to the design that we created. This was utilizing laser cutters, CNC machines. We also had 3D printed parts to make sure that we have all the components to have perfect alignment and a full assembly. And from here, this is just the Gantt chart. So obviously each project, we want to have a very clear map of how we're going to design it, how we're going to procure it and manufacture it, and then the test plan and validation, and then the delivery, right? So there's this whole element of planning what you're going to do, figuring out why you're going to do it. Then from there, making sure that we're purchasing accordingly, right? We don't want to buy too much, but we don't want to buy too little, especially with supply chain demands. So really the material procurement and manufacturing takes about 5 months to make sure that we have all the right parts, and then the assembly of all those parts. Once we have the assembly done, then we can start doing the testing and validation, which is done in our laboratory as well. So yeah, so we're hoping that, you know, this product or this prototype, obviously this isn't the end of it because it's not to scale. So we have the 10 kilowatt validation that we've already done. We're moving into the next phase, which is scaling back up to 100 kilowatt prototype. And from there, we can show that, okay, our algorithm that we do computationally is matched with what we can build in the laboratory and what we can test in the laboratory. And then we scale up to 100 kilowatts. That's going to show that our design tool is scalable, in which case we can prove that the power density that we were able to achieve at the 10 kilowatts in our laboratory will be on to a high degree accurate when we scale it up to 20 megawatts. And so that's what we're still in the middle of proving. In addition to that, we also are working on future machine concepts. Specifically, we're looking at superconducting material in order to achieve even a higher power density. And this is something that is more in the lines of maybe, 5 to 10 years out. But right now we're setting the groundwork for material characterization and making sure that we understand what is the material that we're working with. And so this is where we're at, and I'll stop sharing for a second. So that is the project and how we utilize our Makerspace, in particular, how my company utilizes the Makerspace. Are there any questions before I move on to a description on the actual Makerspace?
No question. I just would like to say it's wonderful for us to hear how something like a 3D printer is used at this high level to prototype something of this high level, whereas we would use them in our Makerspace at, where a lot of us are beginning and just starting out doing fun things. So it's nice to see where this can really go.
Yeah, and I see that there is a question regarding, are there applications for electric trucks? So absolutely, and with electric motors, it's very interesting because there's a lot of different variations of usage for electric motors. There's also a lot of topologies. meaning the way in which the stator and the rotor are interacting determines the topology or the family of motors that it works in, that is being labeled under. So what we are working with is permanent magnet synchronous machines. These are utilizing very strong magnets or rare earth magnets, which are used in electric vehicles as well. So the Tesla has a PMSM, a permanent magnet synchronous machine or motor inside it. Electric trucks, obviously there are other criteria that you would want. So you would want high torque because it's a very heavy vehicle. So in order to get it moving, you need that torque to drive the machine forward. And ours is low, high torque, low speed. So yes, it could be applicable to electric trucks as well. And all right, Anik, do you have any other questions?
No, sorry, I forgot to take myself off mute.
Okay. All right, the next presentation that I have is from the an organization who has created an academy for software engineering. This is, I think, one of the most concise presentations on Makerspace. They call it an ideas lab, but I just really like this presentation as it walks you through how to define and conceptualize the Makerspace. So I'm going to start my presentation, or the presentation. Okay, so this is, you can refer back to this presentation anytime that you want. It's through Prezi. It's by a person named Jonathan Rothman, and he put this together for the individuals at his Makerspace. And so just to start, what is the definition, or how would you define Makerspace, right? So I think that this is a beautiful description. It's basically a space for collaborative exploration, right? It's definitely cross-disciplinary, where, for instance, the electric motor example that I gave you, we need to utilize electrical engineers, mechanical engineers, design people, Navy application specialist. So all these individuals have specialized in a certain area, right? And now they're having conversations with each other to come up with one goal. Often, but doesn't have to go along with desktop manufacturing tools. And we'll get to those in a bit, but those are like your 3D printers or laser cutters or things that go on a desktop and can create some type of product for you. And then a makerspace is more of a mindset and not a set of tools. So really figuring out, what it is that you want to create or what concepts you want to explore, and then entering the makerspace with that in the forefront of your mind. So I kind of described where I'm coming from, but as a research and developer, makerspaces are a way of life. This is what we do. We have many people from all across education levels, as well as economic status levels, that come in and explore their ideas within the makerspace. But myself, I'm from higher education and am creating a business around makerspaces, as well as developing innovation and inventions. All right, so this is an example of a makerspace that is fully functional and more geared towards students. However, I think that this is a great demonstration of many makerspaces all across the US, and in particular what the Bean Path is trying to achieve. So equipment and machinery, this is all the way from electronics and circuitry So using Arduinos to program, or electronic components to fabricate a PCB board, as well as soldering supplies to create wiring on those PCB boards. Also sketching tools, so paper, pencils, cardboard, drafting tools. All of this is a part of the equipment to make something, right? Even in my high-tech lab, we're using cardboard right now to make examples of sheet metal and where we want them, because we have to start somewhere, and cheaper is always better than going straight into fabrication, if you can help it. Computers obviously are very strong in today's world. We can create a lot of simulations of the work that we would like to produce inside software. Like I said, you want to decrease the costs of your front end idea creation. So if you can do this in a computer program where you're not wasting material, it's going to be a lot less frustrating and a lot less financially intensive. And then workshop tools. So in our lab, we have, metal benders, acrylic bending machines. We have drills, drill presses, saws, all the woodworking tools and metalworking tools. So to get on into the 3D printers, which are pretty advanced, I think. I mean, we have 3 in our lab, and they're just incredible machines. It's great for prototyping and testing different ideas. Definitely, you can use a wide variety of materials. This says different types of plastics, which is true, but you can also utilize 3D printing with metal as well, metal additive manufacturing. In our lab, we have high performance polymers and also carbon fiber embedded polymers, filaments that are fed into the 3D printer. You use a software, a 3D CAD software that then basically transfers the design into the 3D printer, and then you start printing, and you'll get your end product at the finish of the print. Now, it seems easy, right? You create a design, you put it in the machine, and it prints, but that's not actually the case. There's a lot of nuanced information that you can gather based on the materials. So what is the material that you're printing with? What is the strength that you need? All depends on the type of printing pattern that you're going to be using. All right, laser cutter. So this is a high energized laser that can etch and cut into materials such as wood, acrylic, thinner materials specifically. And this is really a powerful tool for kind of finishing prototypes, or maybe if you want to do like two-dimensional cutouts that you will fit like puzzle pieces together in a 3D part. There's a lot of hobby level laser cutters. We in particular have a full spectrum laser in our facility. We use it for cutting out acrylic enclosures. So when we make our enclosures for specific prototypes, we have the laser cutter, which cuts it out in super fast, super accurate, and wonderful. CNC routers are more for thicker materials. So we're talking plywood, hardwood, thicker acrylic, all the plastics, aluminum, as well as PCB boards. And these are basically, you have, again, you're inputting computer designs into these machines, and then it's automatically doing it. This is great if you want to reduce time in the fabrication and work more on your design. So a lot of the furniture that we have in our lab is, obviously the lab furniture, and then they call it classroom furniture. I like to call it, collaborative furniture, where you can move the spaces around. The lab furniture needs to be super sturdy, especially if you're running equipment on top of the desks. And so that's kind of, you know, where we lend our focus is towards conducive environments for exploration, building, communicating, prototyping. So there's a lot of different CAD software out there. I would definitely recommend, if you're new to it, to start exploring SketchUp, and that is a Google product. I think it's free to access and to use. And there you can start to work on, you know, the 3D drawing skill sets. If you want a little bit of a step up, Autodesk offers a program called Fusion 360, and I believe it's free for hobby interest. And then if you do have a small company or your own company, you can actually request for a free subscription from Autodesk. I think it's for a year or 2 years, which is the startup deal. Also, there's Illustrator, Arduino, and there's, you know, SolidWorks, which is much more computationally heavy. You can do computational fluid dynamics, also finite element analysis with SolidWorks. There's a lot of very interesting add-ons that you can put into Fusion 360 as well. So it's just a really amazing, powerful software, any type of CAD software. I think CAD stands for computer assisted design software. So there's a wide range of, it's a broad category. All right, so what is key to having a successful makerspace is organization. And I can't stress this enough. It's so important to make sure that the space that you start in is clean and clear, and you have room to create your ideas. Everything has a place, and everything in its place is kind of what we live by within our lab, making sure that we have inventory count, so we're not in the middle of a project and then something runs out, is going to be key to success and reducing frustrations. So this is an example of organizations, but I can tell you that our lab is pretty much up to this standard as well. Every box that we have is labeled. All these little smaller components are in its own little cubby holes, and those are labeled. All of our tools have different drawers, so that's really important, especially with makerspaces that are community driven, where you have many people going in and out. You really want to either have your own, maybe your own toolbox, or maybe you know, you take ownership over a space in the makerspace so that you can set examples for other workbenches as well. But really taking on the organization as serious as your project. Yeah, so just reiterating, label everything, find the right combination of storage and shelves and storage bins, make sure that everything's set up so that you have easy access, but then also that you have natural barriers, and then also asking for maybe volunteers at the makerspace for help in that organizational practice. Purchasing, so there's a lot of different ways that you can purchase your tools or your extra pieces that you need to create your project. I would recommend a couple of different sites: DigiKey if you're doing electronics, McMaster if you're doing metalworking, and also Granger is a great one for lab organization. I would say also with check in your local area for bulk materials as well, so like wood or sheet metal. Each city has its own type of bulk supplier, wholesale suppliers for different materials, especially if you find yourself really wanting to do like furniture making. Perhaps there is like a wholesale wood working store in your area. So I would say reach out to your local community and see who's selling what and what they specialize in. Everybody is also really willing to answer questions and to share their expertise. So getting out there, making phone calls if you're interested in a particular area and you know that you need a certain material, looking for those vendors and being proactive. Just because you make a phone call doesn't mean that you need to spend any money. You can call these suppliers, you can ask them questions, and you can learn about that material. They're always offering their knowledge up. And all right, so I think this is done. I'm going to stop my presentation. All right.
Fantastic, thank you. That gives us all some great insights into what a makerspace is and what you can do. And as I said before, it's wonderful to see, at what levels you can use it, whether it's as a hobbyist or as a professional, or on an industrial sense as well. We have a couple of questions coming through. Transparent wood with a way to question: how do makerspaces successfully help minority makers with no family history in business become entrepreneurs and business leaders?
That's
Go
ahead.
I was wondering, do you have a experience in this area with your makerspace?
Yeah, so I think that there's a couple of different, so our makerspace is in an accelerator. So the accelerator is the entrepreneur, business leader training type of facility. The makerspace is within the accelerator. And so, for instance, the makerspace successfully helps minority makers because in these maker spaces, it's very much open-ended exploration, do as what you want, but also working with other people. So this is a really great way to exercise that type of how do I, as a person who wants to be an entrepreneur or wants to create things, how do I work with other people? How do I build teams? How do I come up with an idea and then bring it all the way to fruition? Am I okay with this, with the failure that comes along with it, right? Because each part of these stages, we're going to learn more about ourselves, and we're going to learn more about how to create a process that's going to lead to success. I would say that maker spaces, for me, have traditionally been, there's always the idea of okay, I am a minority and I'm a woman and I'm in a space that is not primarily women or minorities. But when I enter into my maker space, it's almost like everything falls away because the goal orientation is what I'm going to build. And so how I build it is the only thing in my mind. And if I am open to learning from other people, but also staying true in my own intuition, then it helps with building confidence, with building skill sets, and also taking on more and more responsibility within these organizations. To build a business is a huge jump from an idea to a business. And I think that requires a lot of mentorship and also thinking through your business plan, which is a completely other side of the coin of building something, right? So maybe we can make a pen in a maker space. We say, okay, I really like this pen. I'm going to make this pen. Can I do it? What is involved with making this particular item. Now you think about it on the business side and you say, okay, well, I can make one for $3, right? But then I will have to sell it for $10 to make up my cost for my tooling and my marketing and everything. However, there are hundreds of thousands of pens on the market today for $2 a piece. Is that economical? Will I be able to create a business with that? And so that's the other side of the coin. Makerspaces are there to help you grow and learn in your skill sets. I think accelerators, incubators are there to help grow on the entrepreneurial business side.
That's a really nice definition of, I think people get confused around where a makerspace sits in the creative process of a business. So that's really helpful to clarify. And I know with Beanpath, we have various people that do help with business plans, which is about, how much is this going to cost? We can make 100 of these for $10 and marketing plans and things like that. And we also have experts around us. And in the future, the Makerspace will be in an innovation lab. So as we grow, we'll be able to bring in those expertise actually quite literally on the ground as well. So yeah, it's very exciting that you have it already all in one space, the incubator and the makerspace. So you can go from crazy idea to reality to sales, as it were. Mm-hmm. It says, we have another question. It says, do you have a list of experts on call? I'm not sure if that's, I think so for your makerspace, mm-hmm. Do you have experts on call so that anyone can go in and they have their idea and the experts can support them to go, oh, okay, well, let's look at this on a 3D printer or a lathe cutter, or how do you work with somebody that walks in the door with an idea?
Yeah, so basically each one of our machining equipment pieces has an owner, is what we call it. The owner is responsible for the maintenance of the machines. It's for the owner basically does all of the maintenance on the machines, trains individuals on that machine. And then if there is a person that wants to have something printed or cut or anything like that, they can just request for that owner or that expert to do it for them. And in terms of my own personal company and how I built it was I really made sure to put relationships in the forefront, starting from a pretty young age, starting in like when I was 18, 19, 20, making sure that, relationships are one of the most important and also expensive elements of life. And not only for love and for compassion and friendships, but also for learning and developing professionally as well. And so in doing that from a young age and making building my relationships with my mentors, with my professors, today I can say, yes, I do have a list of experts, or at least people who are knowledgeable in an area, that I can pick up the phone or send an email to and schedule a meeting with them to dive into deeper some of the issues that I'm having, either with myself on the entrepreneurial side or in the laboratory side. And that is something that has taken a long time, but I definitely recommend doing that. And it doesn't always take a face-to-face. I definitely utilize LinkedIn a lot. So really anything that I'm interested in or anything that I'm having issues with in my lab, I go on a deep dive research project utilizing the internet, utilizing LinkedIn, and sending messages out and saying, this, like, hi, my name is Dr. Nyah Zarate. I work on this project. I would love to talk to you or pick your brain about X, Y, and Z. And I am very surprised and pleasantly surprised that people have been more responsive than not in doing that.
I would like to add to that for our audience as well. You do it the other way around. So actually, Dr. Zarate reached out to us. She heard about Nashli's work, our founder, and reached out to us to see, how we could help and collaborate, how she could help and collaborate, and to find out more about us. So I think it works both ways. And thank you so much for being interested in what we're doing and supporting our community here, because this is, whilst making and creativity from arts to business is very much part of the Mississippi Foundation, and it's in our culture. We've never had been able to really come together and have a makerspace and to build on it. Although there are some makerspaces here, but hopefully with what we're doing here is about really building up and strengthening that community. One thing actually, I wanted to go back to the last question in relation to the small, the minority businesses. I know you identify as, am I right? You identify as Latino, is that correct?
Mm-hmm. That's correct, yeah.
We hadn't actually had that conversation. I'd read about it, so I thought, maybe I should have checked beforehand. And you also mentioned previously when you were talking how, when people walk in, they walk in with an idea. They walk in with a certain skill set, and nobody has all of the skill sets. And I think one thing that's really beautiful about, for me, is a makerspace is, now correct me if this is not the correct terminology, it's a neutralizing zone. It's like nobody knows everything, and where you've come from, it's got nothing to do with it. So if you just have an idea, you have a curiosity, it neutralizes it. Everyone's the same in that sense. Now I feel like I'm saying that in a very weak, flippant kind of way. I'm wondering if you could talk to that and your own personal experience in that area.
Yeah, so I think that it's really important to always, for anybody, to go into a new place humble, right? So often I walk into my lab, even this last week, humbled, because my team members are well versed in certain areas that I'm not. And so it's important for me to go into a space with open-mindedness, to be able to absorb what they're saying to me, and to be able to interact with clarity, and also to be able to advocate and speak up for myself at times where I need to. I would say that in the end, we're all just trying to do the best job possible, right? So we're all trying to accomplish a goal, and we are all passionate of the areas that we feel we know the most. And it is a neutralizing zone, in the fact that our objective or our goals in going into the space are aligned, and for that everybody can contribute in the way that they do best. So I don't know if that answers the question, but I do think that it's for me, STEM or STEAM areas have been a place of refuge more than a place of because all the differences are really celebrated, rather than needing to conform. To make a good researcher, to make a good scientist, to make a good artist, you need to think outside of the boxes and outside of the bounds of what you've been told. That's the only way that new things can ever be created. And so this for me is a place of comfort and excitement and really exploration.
That's beautiful. I'm going to steal that. That a makerspace is a place of refuge. I feel I feel that very much so. And it's wonderful that you've been able to create that and support that in your community as well.
It's exciting. It's very exciting to see what ideas people can explore within the Makerspace, and the more capabilities that we add to the lab, the more we're seeing the ideas come to life, right? So it's very exciting.
I was wondering, I know that you are, as you mentioned, reaching out to people, and you reached out to us, and I know you're part of a larger group, the national, I mean, this is a national movement. Makerspaces are a national movement that's growing, and it's quite united, and you're part of this group. And I think it's really nice that people know that walking into a makerspace, yes, it's about your community and your space and your ideas, but it's not just even reaching out within your community, but it opens up the doors for, like, nationally, actually internationally. I was wondering if you could talk a little bit about just the nationally, the community that you're part of as a maker.
Yes, so a lot of this kind of overlaps with the community that I developed through schooling. So higher education provided me the opportunity to connect with individuals all across the US, and is particularly working in the makerspace realm. You have many forums online at your disposal right now as we speak, right? So if you're interested in anything, the internet has provided us a means to connect. I'm in Portland, Oregon right now. Anika's in Mississippi, and Nashley is in Atlanta. I have makerspace friends that are in Boston, and so it's just incredible with Zoom and with all this technology that has emerged. We can connect as individuals and discuss these projects or the concepts of these spaces across time and space. Here in Portland, we have many maker spaces, and so we're able to interact with each other and figure out what the best configuration is for the aim or the mission of that maker space, right? I'm also working within a network of accelerators as well. So this is on a national level. We're talking about entrepreneurship within the STEAM sector. So how do we build viable businesses and business leaders within the area of STEAM? And so right now we're working with a small group of us are working in the Pacific Northwest, but we are determined to take this nationally as a program for minority BIPOC specific accelerator programs. And this is based on our own research that we're doing, talking to individuals who have desires for entrepreneurship we're starting with the Latinx community, but this can be also expanded into Indigenous as well as Black communities, where we can create space for the discussions, the knowledge, the exchange based on desires to pursue that entrepreneurial journey.
I seem to be having a little bit of a technical issue here. Can you hear me?
Yep, I can hear you.
Oh, great, fantastic. Sorry about that. Yeah, that's so, I think that's one of the things that's so beautiful about Maker and this STEAM world. It's very uniting. And at the end of the day, the way I think I definitely see it as it's problem solving, and it's problem solving problems. There's social issues. Design and creating things basically are done because of an issue for a human being, whether it's a social bigger issue or just a personal irritation, as it were.
Mm-hmm.
And I think it's beautiful that it's a way of us coming together through this. Okay, so I think we're coming to a close. Is there anything else that you would like to touch on before we close up, Dr. Zarate?
I would just encourage everybody to, if you have any mild interest in STEAM or makerspaces, to start a mini project, or to start a journal in which you can just write down your ideas, sketch out something, and start going into your own individual makerspace. Makerspace doesn't necessarily need to have tooling, right? It's a mindset. So growing that curiosity seed within your mind, utilizing the items that you have around you, whether it's pen and paper, or whether it's a whiteboard, or whether it's even paint on, I don't even know if paint exists anymore, but PowerPoint, for instance, or mood boards, or whatever it may be, any type of item around your house that grasps your interest, whether it's a coffee maker, whether it's a microwave, figuring out like, how does it work? What makes it work? What makes it attractive? What doesn't? What makes it not attractive, right? How could you improve making a more sexy coffee maker, and what that would look like? And if you're interested in the microwave, and what makes the food hot when you stick it in the microwave, right? So getting curious about the world around you will then open up many, many doors into the pathway of, when I enter into the maker space, I have an idea of where I want to explore, or what I want to explore. And I just can't stress getting anything that sparks your interest, getting curious about why that's interesting, and then exploring deeper and deeper, and going into the rabbit hole of sorts, and utilizing the resources around you. I would just like to add that that's kind of helped me along my way.
That's beautiful and inspiring. Thank you so much. And just generally, thank you so much for your insight into the world of Maker that you've given on the different levels, making it real for us, your support, and for being here, your support of what this creative STEAM and tech community in Jackson are doing. We really appreciate your time. It's been fascinating to have you on the show, and just thrilling to hear about your world of Maker and the community, and also how to get involved with it. Tech talkers out there, I hope today's Tech Talk has explored something new for you and made space for innovation in your mind. I think Dr. Zarate put it beautifully. It's a mindset, but that's all it is. I hope this has demystified some of this world for you, and it's opened it up and titillated your interest further into the world of STEAM and tech. So if you have a topic you would like us to discuss, or someone to interview, please let us know. Like the Makerspace, these tech talks are yours. We hear your requests, and we do our utmost to respond by sharing our network, our skills, our expertise, people like Dr. Zarate. And so keep your feedback coming. No topic is too simple or too crazy. The world of STEAM and tech is, I think Dr. Zarate would agree, it's a vast world, and people that are in it are all really excited to share it with you, especially here at Bean Path. So for further information on all of our programs, our help desk, CTO to go, and our outreach. Please jump onto our social platforms and support us by liking us and sharing our posts. As I mentioned, the Makerspace will be opening to the public in the fall, and so a lot of new opportunities for people to get involved are coming up. So so stay tuned, and again, as Dr. Zarate so beautifully put it, just stay curious. Thank you.
Bye. Thank you.